Most of the world is covered in water. Earth's water flows in rivers and streams and collects in lakes, oceans, and below Earth's surface. 97% of the water on Earth is saltwater, which is found in the oceans and other smaller bodies of saltwater. The other 3% is freshwater. About 2% of freshwater is frozen on Earth's north and south poles. That means just 1% of Earth's water provides the fresh water that all plants and animals need to survive. Think of some ways you use water every day. There are other ways you use water that might surprise you. Manufacturing uses a lot of water. For example, it takes 2.5 gallons of water to produce 1 sheet of paper. It takes 70 gallons to make 1 pound of plastic. Growing food takes a lot of water too. Growing a single apple can take about 18 gallons of water. People can get the water they need from reservoirs of water on Earth's surface, or underground bodies of water called aquifers. Systems of pipes and pumps carry this water into our homes and businesses. Aquifers and reservoirs are refilled by rain and other precipitation. This works well when precipitation adds as much water as people take away. When people use too much water, water levels fall. Aquifers and reservoirs could dry up completely. This can easily happen when there is a drought or time with very little precipitation. Conservation can keep people from running out of water. Conservation means the careful use of resources such as water. There are many simple ways to conserve water at home, such as turning off the tap while you're brushing your teeth, or collecting rainwater to water plants. Governments also help by passing regulations such as limits on watering lawns. Factories and farmers can also find ways to conserve. For example, factories can filter dirty water and reuse it. Farmers can find ways to conserve as they water crops. This system drips water right into the soil, so the water doesn't run off or evaporate. Pollution is another threat to our supply of fresh water. Chemicals that people use in our homes and factories go down the drain and into our water supply. Rain washes fertilizers from fields into rivers and lakes. Rain can also wash trash and pollution from city streets into water sources. Pollution makes water unhealthy for plants, animals, and people. Different kinds of pollution have different effects. Nutrients from plant fertilizer can cause an algal bloom in a lake. This increase in algae can kill fish and other species. Some kinds of air pollution can cause acid rain. Acid rain can make rivers and lakes acidic, which harms wildlife. Other kinds of pollution also kill fish and make water undrinkable. Fortunately, there are many steps people can take to care for our fresh water. Some kinds of pollution can be cleaned up, and more kinds of pollution can be prevented. Farmers can take steps to prevent fertilizer runoff. People can avoid putting harmful chemicals down the drain. New technologies may be able to help. For many years, scientists have been developing better ways to remove salt from ocean water to make fresh water. This is called desalination. One of the world's largest desalination plants is off the California coast near San Diego. Fresh water from desalination can be an important source of water during a drought. Follow the news to learn about new technologies that are helping to protect our water supply, and see if you can find ways to help.
Hello, this is Mr. Travers, and we'll be discussing what is pH. pH is a measure of the acidity of a solution. It is an inverse measure, meaning that low pH indicates high acidity. An acid is a substance that releases hydrogen atoms when dissolved in water. For example, when hydrochloric acid dissolves in water, the hydrogen atom separates from the chlorine atom. A water molecule then binds with this hydrogen atom, producing a hydronium ion. As more acid is added to a solution, more hydronium ions form. So a high concentration of hydronium ions means high acidity. The concentration of these ions is the measure of acidity. that pH refers to. The letter H in pH is a capital letter because the symbol for hydrogen is capital H. This pH scale shows the inverse relationship between pH and acidity. Small numbers at the top of the scale indicate low pH and high acidity. Large numbers at the bottom of the scale represent high pH and low acidity. In the middle of the scale is the pH of 7. This is the pH of pure water and is called neutral. Substances with lower pH are called acidic, and substances with higher pH are called basic. Normal rainwater is slightly acidic with a pH around 5.6. Acid rain is more acidic, so it has a lower pH, as low as 4.5. Acid rain is a pollutant and is harmful to plants, animals, and humans. Regular white vinegar is a stronger acid with a pH of 2.4. Common basic substances include baking soda with a pH of 8.3 and glass cleaner with a pH about 10.8.
Hello everyone. Welcome to another Ancient and Medieval Adventures Camps lesson. In this lesson, we are going to be talking about one of the Roman Empire's greatest inventions, the aqueduct. Today, we are going to find out what aqueducts are and why they were built, how aqueducts work, who built aqueducts and when they were built, and why aqueducts are an important invention. Let's get started. In the earlier years of the Roman Empire, Romans accessed their water through springs and wells. However, the city of Rome had been rapidly expanding over the previous years, and the population of the city was getting too large to support using these means. While the city was built near the Tiber River, it was far from larger water sources, and let's face it, it wasn't very clean. So in order to get enough water for the growing city, architects had to come up with a way to move large amounts of water from somewhere far away into the city. Thus, the aqueduct was born. So how exactly do aqueducts work? The purpose of an aqueduct is to transport water from a reservoir or a place with large quantities of water, like a river or lake, into a city where it can be used. An aqueduct was built starting at the site of the body of water, where an intake system was used to channel the water into the aqueduct. The water would then begin to move through the aqueduct toward its destination. Often, the aqueducts were built with a gentle slope so that gravity could help the flow of water without the need for pumps. Aqueducts were most frequently built below ground. The water traveled through underground tunnels to reach its destination. However, in cases where the channel was interrupted by a valley, architects and engineers constructed above-ground bridges to carry the water across. These bridges were built out of stone and concrete, and many were so sturdy that they are still standing today. The water taken from the reservoir could travel hundreds of miles through hills, valleys, cliffs, and more to get to its location. The other end of the aqueduct would be at a location within a city, like Rome, where the water was collected in a reservoir and could then be drawn for daily use by the people of the city. The water brought by aqueducts had many daily uses in the city of Rome. The water helped drain public toilets, provided much-needed moisture for gardens and farm work, and filled decorative fountains, as well as Rome's famous and grand public baths. Roman baths were one of the largest facilities for which aqueduct water could be used. These baths are not baths in the way we think of them today. They were more like public swimming pools where Roman people would go to socialize. These baths were also very important for Roman politics, as Roman senators would often gather at the baths and talk about political decisions that they needed to make. But the Romans didn't always have these water sources. The very first aqueduct was commissioned in the year 312 BCE, which is less than 3,000 years ago. The first aqueduct was built by Appius Claudius Caecus, a Roman architect who is famous for building the roads in Rome. By the fall of the Roman Empire, there were 11 different aqueducts built within the city of Rome, as well as many others throughout the rest of the Roman Empire. However, aqueducts took a very long time to build, up to 17 years. They were also quite expensive, and for a long time they were built for private households, usually for richer families who could afford them. That is, until someone came along to change that. Marcus Agrippa was a general under the Roman Emperor Augustus, but he was also skilled at many other things, including architecture, and had a great love for the city of Rome and its people. Agrippa wanted to make aqueducts more accessible for the Roman people, so when he was elected to be in charge of the city's buildings, he restored and created new public aqueducts that all the people in Rome could use, not just the wealthy families. He also made improvements to the design of the aqueducts so that they worked better. He also built a beautiful new bath complex for the people, supplied with water by the aqueducts. Agrippa's generous act made the Roman people very happy. For his architectural genius, Agrippa was given the title Master Builder. While they were very popular with the Roman people, aqueducts also have a lasting impact today. In ancient Rome, aqueducts were useful sources of water that were invaluable to the expansion of the Roman Empire. In modern times, aqueducts can still teach us a lot. These long-lasting structures have given architects many ideas for how to build things to last longer, and we are still working to perfect the recipe for Roman concrete that was used to make the aqueducts. Most notably, aqueducts have had a great influence on our modern plumbing system. Aqueducts were a prototype version that inspired humans to figure out new ways of moving water in order to be able to use it in our homes. Thank you for watching. We hope you enjoyed this presentation and are ready to get crafty. It's time to do as the Romans do. Put together an aqueduct of your very own and test it out with the materials in your Adventures pack. Don't forget to check out our WordPress pages for more lessons and craft ideas.